just how common these dimensional errors are. Junk, 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 garbage, nonsense. You see it again and again. It's so easy to do. I do it. Every modeler does it occasionally. Setting the value of a flow equal to the value of a stock, or a fraction of a stock. This flow is 50% of this stock value. Subtracting a flow from a stock. Just subtracting it off. If you want to subtract off the flow from a stock in a meaningful way, you subtract off the flow times some unit of time from the stock. And then you get person minus person. Comparing a stock and a flow. Is the stock greater than the flow? Folks, why is that meaningless? It seems so tempting. I mean, setting a value of a flow equal to the value of a stock. Comparing a stock and a flow. Why is that meaningless? Because, folks, it's going to be critically dependent whether that model works. Its behavior will be totally different if you switch your unit of time from years to weeks to days. Because the flow will be totally different. Do you see that? You want your model to be able to have behavior that's consistent when you adjust the time. And if you're comparing a stock to a flow, you depend on the vagaries of what your unit of time is. The consistent way to do it would again be to have this constant that converts, per unit, multiplies by the appropriate unit of time. So comparing a stock and a flow, scale divergent behavior, totally different behavior if you're switching your units of time. For a flow, multiplying rather than dividing the value of a stock by a time constant. So if we have an average time in that stock, and we multiply the stock by that. So if we have a stock that measures people in persons, and we have an average time you spend in that stock of 10 days, an average time in the stock, maybe it's 10 days, for example. If we multiply the value of the stock by that length of time, what's the resulting dimension of the resulting value? What is it? If we have persons in the stock and then we have some amount of time in the stock, mu, we'll call it, the average time you spend in the stock. Maybe it's the count of infectious people. It's the average time you spend infectious. If we have a value for the flow out of the stock, that's the stock times that amount of time. What's the units, or what's the dimensions of multiplying that stock times that mu value? It is what?
Person time.
Yeah, person times time. What do we need for that flow? If we have a stock of dimension person, what do we need for the flow? It needs to be of dimension what? Yes. Needs to be person per time. That is the key thing you got to keep in mind with stock and flow models. You have a stock, the flow has got to be the units. If you have a stock measured with dimension d, the dimension associated with the flows has got to be of dimension d divided by time. It has to be. Because of how the model is, the semantics of the model. Again, the integral that takes place there. Flow times dt, summing it up. It's got to be that flow as dimension of the stock divided by time. Or if for a flow you divide by the stock by a coefficient, by a hazard. A hazard, in other words, likelihood per unit time, If we do that, we divide by it instead of multiply by it, then once again we're going to have the flow. So if we have this hazard, it's of dimension 1 over time. We did that earlier, alpha. And so if we have x divided by alpha, we get something of person time. Okay, so let's try doing a bit of model analysis here. A classic